Welcome. Thank you for joining me today. The focus of my presentation is on classroom practices that support all learners in developing robust statistical reasoning. I'm Gemma Mojica from NC State University. In this presentation, I'll share my rationale for this focus, some general recommendations for classroom practices that develop student statistical reasoning, some very specific classroom practices that focus on data and statistics, and finally, I'll share an example of a task that engages learners in an investigative process with data. Throughout the presentation, I'll share resources for educators that can be found in a handout available in the resource room, and it will include all links to the resources. I want to begin with my rationale for this focus. Many recognize that it's very important for students to be prepared for pathways that lead to careers in data science and statistics, and that it's important for everyone to have data literacy. Decades support has included statistics and data in K-12 education. The National Council of Teachers of Mathematics, the American Statistical Association all have guidelines for including data and statistics. The Common Core standards continue to include these when adopted. Many state efforts also focus on including data science and statistics in grades 6 through 12, and many have started to include data science specific standards in their states. Although there's been this focus of inclusion of statistics and data science in students' K-12 education experiences, we know that often students, when they graduate, are underprepared with statistics and data skills. This makes a career in data-intensive careers unobtainable for many students. Another challenge in preparing all to be data literate is that teachers are often trained in programs that don't support becoming effective statistics and data teachers, that have robust understandings of the key data and statistical ideas as well as practices. So, to prepare all students who are data literate and ready to pursue careers requiring data science and statistics skills, it's imperative that teachers effectively integrate data experiences into an already packed mathematics curriculum. So, we know that there are some recommendations from different organizations. For example, I'm going to share some recommendations from GAZE that provide specific things that we should be focusing on in classrooms. One is that it's important to ask statistical questions throughout a statistical problem-solving process. And I'll talk more about a statistical problem-solving process in a moment. We know that it's really important that students have opportunities to consider different types of data and variables, and we know that they need to think about planning while they're thinking about collecting or considering data. And they also need to engage in processes like collecting data, cleaning data, interrogating and analyzing data. It's also very important to provide opportunities for students to build multivariate thinking, and this is throughout their whole K-12 experience. We also need to provide opportunities where students engage with tasks that provide probabilistic thinking and they quantify randomness and uncertainty. And we know that when we're thinking about modern day statistics, it's going to involve the use of technology. We also know that recommendations tell us that it's really important for students to accurately communicate and clearly communicate, and that the role of assessment is very important when we want to measure students' conceptual understanding and reasoning about statistics and data. So I want to take a moment to think about an important job that teachers do in the classroom. I think of teachers as designers. Teachers design learning environments for students. And we know from literature that there are things that teachers have to focus on, but then they also have to integrate knowledge around these ideas. So, for example, focusing on tasks is an important place to engage students and to build students' statistical reasoning. And so even if we think about mathematical tasks, not specific to statistics alone, we know that it's really important if we want to engage diverse learners in providing opportunities for students to engage in low floor, high ceiling tasks. these types of tasks allow students, no matter what their background knowledge, no matter what their skills, no matter what their experiences, to approach a task. And it also provides opportunities for students to extend the task in ways that make sense for them. Another framework you could think about when choosing tasks, whether they're statistical or mathematical, is that we know that cognitively demanding tasks promote conceptual understanding and the development of thinking and reasoning and problem solving. So these tasks often require students to think in complex and non algorithmic ways. They require students to explore and understand concepts, relationships, practices, and processes. It requires students to monitor and self regulate their own processes while they're engaged in a task. So, starting with tasks is very important, but it's not just important to think about the task you're going to provide an opportunity for students to engage with. It's also focusing on other aspects of creating learning environments for students. So, in consideration with your task, you also have to think about what are these important data and statistical ideas. So, what are the central fundamental ideas that I want students to understand? And then another overarching concept that's really important for teachers to focus on is what are the practices and the processes that I want to engage students in? And those kind of overlap all of these aspects of teaching. And in relation to tasks, we also have to think, in addition to the practices and the ideas that we want to focus on, about discourse and argumentation. We want to think about assessing students throughout. In focusing on statistics, we also want to think about how the task uses data and the opportunities for using data, as well as technology. And notice in this diagram, all of these different dimensions of creating a learning environment for students overlap. So it's a lot for teachers to coordinate. But there are some ways that we can think about if we're going to focus on statistical tasks that provide opportunities for diverse learners. There are opportunities that we can use from frameworks to help guide the work we do. So what I want to talk about now is a focus on the data investigation process. So I'm recommending tasks that promote opportunities for diverse learners, and it begins with starting with a problem. So in Gaze talks about the statistical problem solving process. Others have used a model called the PCAI model, where they talk about posing a question, collecting data, analyzing data, and interpreting data. And so the work that my group has done is we've taken a look at all of the literature in statistics education and data education, and then we look to see, well, what do data scientists and other professionals that work with big data, what do they do? And so we tried to think about how we could expand and extend the work and the framework around engaging in problems with data to include these ideas from data scientists and other professionals that work with data. So that's the process that I'm going to share with you right now. And again, it goes back to we want students to be engaged in problem solving. So one of the first aspects of that is this idea of we're framing a problem. And so oftentimes in statistics education, we focus on a statistical question or we talk about an investigative question, but we want to take a step back while this is important, and we want to engage students in opportunities to consider real-world phenomena, or important societal issues. We want students to anticipate, well, what's the type of data that may help me solve this problem? What are strategies I can use to solve the problem? And then in the next phase, we want students to either consider data that's already been collected or they're going to gather data themselves. So in some instances, someone may have gathered data, they may even have cleaned the data, and they're presenting data to students. And students need to think about what types of variables are in the data, how were these measured, what kinds of collection or design might have been used to solve this problem. And then they need to also think about maybe possibly other than the design, were there any techniques or what are the types of collection that was used? It's also important, no matter if students are collecting the data or they already have data, that they're thinking about things like what's the sample size? How am I going to access this data, or how am I going to collect it? Where are we going to store it? If the data has already been collected, what's the trustworthiness of the data? And then another important phase in engaging students in a problem that they're trying to solve around data is we have data, whether it's been collected for us or we are going to collect it ourselves. It's this whole idea of processing data. So students need some opportunities to think about the structure of data. Maybe they're going to structure data. They need to be able to think about the organization. They need to think about, do I need to merge different data sets? How would I do this? How would I transform the data? And then what are the techniques and strategies that are very efficient so that I can do these things? And it's also important to think about cleaning with students. Students don't always need to be the ones to clean data, but they need to have some experiences to understand the data, to get an idea of what needs to go on when that happens. They also may need to think about considering collecting more data. So it may be that they decide they need more, but they also might need different variables to answer particular questions. And then we move into the explore and visualize data phase. And so in this phase, what students are doing is they have their data. They want to make some meaning of this data. And oftentimes, this means they're going to use visualizations. And these visualizations could be static, they could be dynamic. And they want to sometimes collect some measures and examine these statistical measures. They want to explore the data for relationships and patterns. And after they've done some exploration and maybe they've considered some models, they've created some visualizations, they have some statistical measures, they then think about, okay, which models help me answer my question? So they want to analyze and identify those models that help them find a solution. And they also need to think about any limitations of the models they're choosing, and they need to think about assumptions about their models. And then finally, in the next phase, it's really important for students to then think about communicating some type of solution and possibly proposing action. So we want them to create a data story to convey the insights that they already have. And it's really important often that they think about, well, who is my stakeholder when I'm communicating this information? So what are the claims and what's the evidence that I have from the data? And what's the action that I can also communicate? And then it's really important when students are working with data for them to address things like the uncertainty, any constraints, limitations, any potential bias in the analysis. So while I talked about these 6 phases of a data investigation process, and it seemed like a very cyclic or linear way, our team that has built on the works of others in this process want to emphasize that we've chosen a model that looks like a puzzle piece to indicate that this is a very dynamic process and you don't necessarily start in one place. It may be that you are considering your data and then you have to go back to frame the problem, and you might have to collect some information in order to make decisions. And so you're constantly going back and forth typically, and you don't always necessarily mark in your own cognition when you are doing this. So it's really important that teachers understand that while we're proposing this framework to engage students with data, it's often going to be a process that you're doing over a whole year or even a K-12 experience. So we don't suggest that every time teachers work with students with data that students need to go through every part of this phase. It's that overall in their overall experiences, students have opportunities to engage in these different aspects. And one other thing that I think is very important to highlight that many in my field talk about are these ideas about habits of mind we want to develop and dispositions. And so, for classroom teachers, while you're engaging students with data, it's really important to think about students making sense of data throughout this whole process that's always related to the context. So that's one of the things that makes statistics and working with data different than just mathematics is that when students are engaged in this problem solving process, no matter where they are in one of these phases, they always need to be making sense of the data about the problem and going back to the context of the problem. And various aspects of this phase may even use different types of technology. So you may clean the data using a technology, but then you may visualize the data using something like CodeApp. And then you may decide I need to do some coding and I might need to use a tool like R. So the technology is going to be used for different purposes at different phases. It's very important to provide opportunities throughout all of these for students to attend to variability and certainty. And you want students to constantly be seeking expertise and information. So it may be that they don't have all the information, so they need to go back and get information from a trusted source, or they may be working together. And so that's an important part is the collaboration, either working in teams together to solve some problem, or it may be, again, in reaching out to an expert or finding expert information to help them. And then again, communicating throughout. So whether it's at the end where they're communicating a solution based on evidence and their claims, but it's also important to communicate throughout the process. And really important is to encourage students to be curious and to be creative and intuitive. So this is really a place where we can support diversity in students, is that building on students' own curiosity and whatever creativity they have, that can really encourage students to think about a problem and use their own intuition and their skills and their curiosity to help them move throughout these different phases. And then we also know that if you're working with big data, it's a process sometimes that is time consuming and you may run into obstacles. So we want to encourage opportunities for students to be built up with their resilience and persistence. So it's okay if students engage and they run into an obstacle and they have to pivot. We want to let them know that that's okay, but then they're going to learn something from that pivot that's going to probably help them move forward. So encouraging them to keep going even if they encounter obstacles. And then two other things that I just feel like are very important to mention in terms of things we want to develop with students to support all learners is we want to encourage skepticism. So as students are engaging throughout this process, wherever it is, it's okay if students are asking critical questions or they're not believing things and they need to find evidence of something. We want to support that throughout. And then lastly, we want students to think about ethical issues and any biases or personal biases that they might have throughout. So this is a framework that we think can be really helpful in engaging students with data that's very specific to building data and statistical thinking. So one of the things that I would like to share right now is I want to share an example of a task that engages students with data. And I just want to show this as an example of how you can engage students and the different opportunities that students could have to develop their reasoning. When I earlier talked about how important it is to think about tasks and choosing tasks that all students can access and that students can extend, or again, if we're using the cognitively demanding framework to think about providing all students access so that they can develop conceptual reasoning and again extend that thinking. I think that this task is an example that would fit into both of those categories, but I also want to highlight the importance of this type of task in promoting the ideas around statistics that I just highlighted as well. So the purpose of what I want to do is to just highlight overall, very broadly, what a task could look like. I encourage you, and I will share the link in the handout I have in the resource room. I encourage you, if you would like, to go through the task so that you can see all of the opportunities for learning to engage learners. We won't have time in the scope of this presentation, but I just want to highlight some things for you. And then on your own, I hope that this might be a helpful tool. As an example of how you can engage students. So this data set that we're going to take a look at has over 250 popular cereals in the data set. It's a multivariate data set. It has many attributes or variables. The data set makes you feel like you're awash in data. So there's so much data that if we were to ask ourselves any questions, or if we were to think of an investigative question or even a problem around this, that if we just had pencil and paper, we could not fully investigate the data. So this requires the use of technology. And the technology tool that we're suggesting in this data investigation, and that will be accessible to you if you follow this link, is in a tool called CodeApp. CodeApp is a free web-based technology tool. It allows for data analysis, but it's also a very good visualization tool. I've used this tool with many different types of learners, from middle school students to high school students to adult learners. And so it's a tool that does not do formal inferential tests, although there are some plugins I think now available that allow you to do this, but it has a beautiful drag drop feature that allows students that are even very young, or students who don't code, the ability to start exploring data. And so that's one of the reasons that we've chosen this tool. So I'm going to go ahead and take you to the investigation and highlight a few things that I think are important to illustrate what it means to engage students in data and how we can support diverse learners. So if you take a look at this data investigation later on, you'll notice that in the process that I described related to the data investigation process, it's highlighted for you on the left. It's not to say, again, that you need to do every single aspect when you engage students, but this is really to give you a chance to engage with many of the phases as you consider this data set. So what I want to highlight on the left is that you can see that we help you think about framing the problem. So we provide a context, an investigative question. Then we also highlight many of the other phases, like consider and gather the data. You might consider and gather new data. You're going to explore and visualize. You're going to think about models, and then ultimately you're going to communicate and propose action. So it gives you opportunities to engage in all of those processes. So I'm not going to highlight every single screen. What I want to do is take you to the screen that shows a data problem or an investigative question. So this is just some information you can see where you can engage students. It's really important to engage them in, here's the context behind this. And so there's some links that students can read, or they can go to, you as a learner can read, or you can go to think about the context of serial, which you would want to set up. We also provide an investigative question for you. This does not have to be the question that you would investigate, but again, it's a way to help you not only think about this data problem, but also to help you think about this process. And as you can see, we've taken into account that, people often think of cereal as a healthy choice, but maybe cereal isn't a healthy choice. Many people I grew up eating cereal as a child, often I think because it was quick, and it was easy, and it was a habit you develop, but is that really a healthy habit? So we have some things to think about in terms of, here are some different commercials that we often see in the media. It might be important to think about, what are these, marketers trying to convey to us, and often they are trying to convey that cereal is a healthy choice. It's part of a balanced breakfast. So the learner can go in and take a look at these to kind of set the stage. But you can see here, we're starting with this broad question: how healthy are cereals? And so this is a very open question. And what you want to start with is thinking about, well, what do we know about cereals? What are some of our common experiences with cereals? And so we often have the experience of looking through these labels. So one thing that you can do to help students think about this idea of considering the data is, well, what are we measuring? So what are all of these different attributes? And students or adult learners, teachers, have opportunities in here. We've provided some links to help you think about, well, if I'm going to think about what's healthy, what does it even mean? What are these attributes? How do they relate to health? So we've provided lots of background for you to examine in order for the learner to think about what they might examine in terms of thinking about health. And again, here are some more links that would help you with that information. And then what you can do is you can start the investigation yourself using this tool. And so if you wanted to do that, you could open this CODAP, document here and do a smaller, work with a smaller data set. So in this task for students, big data may be 77 cereals. So this is an example of, if you need to do some scaffolding and if students aren't quite ready to work with the 250, well, it's actually 269 cereals with all of those variables, it may be more appropriate to start with 77 cereals and 15 variables. So there's an opportunity here for you to engage students. And in this case, this may be big enough for students. And so we have some reflection questions, and this is an example of things that you can ask students throughout. So at the very beginning, I talked about some general guidelines these also match up with the very specific ones related to statistics. But for example, in this one, there are some things that you can ask throughout the data investigation. So things like, do I trust the data? How were they picked? How was this collected? This is an example of questions that you would be asking throughout. And for the sake of time, I'm going to just skip ahead. And then what you can do after you've explored 77, or maybe 77 cereals is not the right data set, and maybe you want to do 269, there's an opportunity here to engage with this. So I'm going to actually just open up the 77. I have just a couple of minutes, and I just want to show you as an example what it looks like when you would open this up with students. So again, I had talked about CODAP and this being a tool. And so if I'm wanting to think about cereal and how healthy cereals are, and I've done some investigation, I can see here the different cases I have. I have 77 cases. There are six different companies included. I can see that I know something about protein, fat for all these cereals. I can go through this in a data card view, which looks a lot like the labels. And then I can also switch to a table, which many students are very familiar with. So I'm going to just show you how easy it is. Let's say I'm interested in sugars. Okay, I can see all of my attributes here. I can see my cases. And let's just say I'm interested in knowing what's the typical amount of sugar in these cereals. How healthy is the cereal? If I think sugar is unhealthy, I can say something about that cereal. So you can see now that I've dragged sugars on the axis, and I can go over to this ruler measure, and I could say, well, what's a measure of center like the mean? What's the mean? And so I know from this view that the mean amount of sugar in the cereals is 6.96. Well, if I want to look at the distribution as a box plot, I can also graph that. So then I can say something about the distribution of cereals and the range. I can say that the cereals range from 0 to 15 grams. I can say something about the centers. They're both about 7. I can easily then start making comparisons about other attributes or variables that I know something about. Like, for example, is there a difference between hot and cold? Are hot or cold cereals healthier depending on sugar? And here I can see I only have 2 hot, but I can start to make comparisons about these distributions. And so that in this case, I might say, well, I only have 2 hot cereals. This isn't enough to make a comparison. This may be something that leads me into thinking, well, maybe we should take a look at this in the bigger case. So I'm going to conclude now. I encourage you to go back and to take a look at this on your own time. I just want to highlight really quickly that there are a couple of resources that I think you could start with if you want to know more about unpacking these practices and habits of minds and dispositions that are going to support all learners. So you can get those in the handout. And then I just wanted to share also my contact information. Please feel free to reach out if you think that I can be helpful to you. And thank you for your attention today. Hi. I appreciate everyone coming today. I love that first question that popped up in the chat. I was trying to pull some links up as I was thinking about that question. That's a great question. And so I will answer it briefly, but then I'm going to pop some links in the chat to show some examples of places you could go to get more resources. So I think one of the really important things to think about across grades 4-8 is that we have wonderful opportunities. So I'm a former middle school math teacher. I try to get back in the classroom as much as I can in middle school and also in elementary schools. So I think that when we work on teams in middle schools, a lot of us follow those models, or in elementary schools where we may teach more than one subject, it gives us a great opportunity to think across. And so things don't necessarily have to be project-based where you're working on a project across all disciplines, but there are certainly ways teachers can either work together or in their own classroom, right? They can try to focus on some standard that might be in a different discipline. So it's the things that like popped to my head when I first saw the question about examples of working across discipline. You saw me using a tool called CodeApp, and the example that I was trying to show looked like it was written more for older learners, but I actually have done like a data investigation using this tool in middle school with students. Using the 77 version of the data set, not the 269. So one, I just want to say that CodeApp is a great tool for upper elementary and middle school students. Like, it's a drag and drop process that allows students to come up with their own questions, to creatively kind of find solutions to the data. So I'm going to drop a link to some example data sets in the chat right now. And if you go to this if you go to this site, there are some CodeApp documents that are already in here that I think are examples of things where students can work across and learn material from different disciplines. So one of the things I know in our state in elementary school and even in middle school later is thinking about plant growth and photosynthesis. So there are some examples in here of CodeApp documents that are already created where students can explore issues around content related to scientific things like plant growth. The four seals example here in the mammal one, they're also great. So for students in science studying like anything about mammals or like animals and their own like how they migrate are great examples. I want to also just draw your attention to some other places where you can go to see where people are doing this. So if you've not been to the Oceans of Data materials, there are lots of great examples here of people working with students in elementary and middle school around ideas around data. So these are very much going to be the ones that go across disciplines. And so there are some earth science lessons here. Like there are things related to geography. There's lots of different examples of things you could look at to give you very specific ways that students can work across disciplines. I'll also say that in addition to both of these places actually use data related to also things like earthquakes or like natural events like that where students can learn about those things. And then certainly climate control or climate change, sorry, is something that comes up. And then one last example, and then we'll see if there are any more questions. If you've not seen, oh, okay, I'm trying to find it, I might have gone too far. Jo Louie's work, she is also she works on the Oceans of Data. Jo Louie does a lot of work in middle and upper elementary where students are looking at things like immigration and then socioeconomic data. So she has some great data sets and some great lessons. And she also uses the tool CodeApp so that students can explore some of these issues that they might see across disciplines. So these hopefully are good examples of some concrete things that you can take a look at to give you examples of working across disciplines. But you can always contact me. I see a few friends in the audience, but if you're around the central part of the state, we would love to support you in supporting teachers or just to support teachers. If you're not, we do a lot of virtual things as well. So please reach out if you have any questions for me that you didn't have a chance to get answered, or if you need more materials or more supports for teachers. And just thank you again for being here.